The Panama Canal is one of the greatest and most ambitious engineering works in the history of the Americas. It was designed to considerably shorten the maritime route between the east and west coasts of the Americas, and also between other continents, preventing ships from having to sail all the way around South America via the dangerous Cape Horn at the extreme southern tip of the continent. This marvel of engineering connects the Atlantic Ocean with the Pacific through an artificial canal and an ingenious lock system that raises ships 26 meters above sea level. With every ship that crosses the lock system, the canal loses a total of 200 million liters of water, running the risk of drying out entirely. But how do they manage to lift giant ships that can weigh more than 160,000 tons? In today's video, we are going to discover together how the Panama Canal works when ships are passing through, as well as the history and curiosities about this gigantic feat that transformed the world more than 100 years ago. Stay with me until the end. I'm Victor, and you're on History Upgrade. I ask that you leave your like, subscribe, and activate the bell for all notifications. Every year, around 14,000 ships pass through the 82 kilometers of the Panama Canal, transporting people and millions of tons of goods from one side of the world to the other. But it wasn't always like this. For centuries, having to travel around South America cost time, money, and lives. And the world desperately needed a better way. Until in 1914, one of the most expensive and ambitious engineering works in the Americas was finally inaugurated: the Panama Canal. Since its opening, more than 1 million ships have transited this legendary route. Connecting the Atlantic and Pacific Oceans by an inland waterway had been humanity's dream for more than 500 years. Uniting these two massive bodies of water would mean an extraordinary advantage for global trade and exploration. It would free ships from a journey of more than 20,000 kilometers, a voyage of nearly 2 weeks. Thanks to the Panama Canal, large ships can now travel from the Atlantic to the Pacific in just 8 hours, which is 40 times faster than the journey around Cape Horn. This transcontinental corridor generates significant revenue for the Panamanian government, estimated at more than $2 billion annually in tolls. Larger ships can pay upwards of $500,000 just to make the crossing. Although the Panama Canal has already surpassed 110 years of operation, it remains absolutely essential to world trade. The canal uses a lock system, closed compartments with gates that function like water elevators. These systems raise ships up to the level of Lake Gatun, which sits higher than both oceans. Then the system lowers the ship back down to sea level on the other side. To appreciate the true importance of this canal, imagine a large container ship sailing through the Atlantic Ocean toward the Pacific. Without the Panama Canal, the entire American continent would stand in its way. Passing through the canal takes between 8 and 10 hours. That same journey, going around South America, requires up to 15 days, a difference of 2 full weeks at sea, plus thousands of additional liters of fuel consumed. But despite all the time and money savings it generates, this man-made commercial route faces a significant and constant challenge. To reach Panama City on the Pacific coast, a ship must navigate through a sequence of narrow, complex channels and locks that demand maximum precision and attention at every moment. The width of the canal stands in sharp contrast to the imposing size of the ships, especially the Panamax and Neo-Panamax vessels, which are built to the maximum dimensions that allow passage through the canal. To cross the canal with complete safety, the expertise of a specialist is absolutely indispensable. And here lies one of the most unique rules in the entire world of navigation. The Panama Canal is the only place on Earth where a ship's captain is legally required to temporarily hand over command of their vessel. That control passes to what are known as canal pilots, highly trained professionals with deep knowledge of the locks, the narrow channels, the currents, and every operational detail of this challenging crossing. They assume full responsibility for guiding the ship throughout the entire route, ensuring every maneuver is executed with pinpoint precision, because any mistake can result in delays, collisions, or serious damage. This requirement reflects not only the complexity of navigation in the canal, but also the critical importance of preserving safety, preventing accidents, and ensuring the constant flow of one of the most strategically important commercial routes in the world. On a normal day, up to 40 ships can cross the canal in both directions, transporting around 600,000 tons of cargo. In 2023 and 2024, the canal faced traffic restrictions due to water scarcity, which temporarily reduced the number of ships to between 24 and 32 per day during certain periods. The idea for a canal connecting the two oceans emerged as far back as the 16th century, but serious construction attempts only began in the late 19th century. It all started in 1881, when the French attempted to build the canal, led by the renowned engineer Ferdinand de Lesseps, the same man behind the Suez Canal. But due to brutal climate conditions, devastating landslides, and deadly tropical diseases such as malaria and yellow fever, the project failed catastrophically, costing the lives of more than 20,000 workers. In 1904, the United States took over the project, but with a fundamentally different approach. Instead of excavating all the way down to sea level, as the French had attempted, the Americans decided to remove only the highest sections of terrain and flood the entire expanse of land behind a massive dam. It was an extraordinary effort surrounded by enormous problems, including disease and landslides that cost the lives of another 5,000 men. Yet the Americans pushed forward with relentless determination. The United States completed the canal in 1914 and administered it for most of the 20th century, until 1999, when the canal was officially transferred to the government of Panama, which administers it to this day. Here is exactly what happens when a ship crosses the Panama Canal from the Atlantic side to the Pacific. 1 hour after entering the canal, the ship advances 11 kilometers from the Cristobal entrance on the Caribbean side until it approaches the first major challenge, the Gatun Dam. Just 1 kilometer further into the canal, the vessel arrives at the first set of locks, known as the Gatun locks. This set is formed by 3 independent but interconnected chambers that serve as the link between the Atlantic side and Lake Gatun, which sits 26 meters above sea level. The challenge here is enormous. With more than 300 meters in length, Panamax vessels are nearly as long as the locks themselves, which measure just 320 meters, leaving very little margin for error. The difficulty isn't just about maneuvering a massive ship. It also carries a heavy cargo of thousands of tons. If the ship is damaged, it will not be able to sail. And if the lock itself is damaged, the Panama Canal will have to close entirely for maintenance, triggering an incalculable global economic loss. To make things even harder, the pilots must guide the ships from a bridge located more than 220 meters from the bow, inside a cabin with very limited visibility. It takes approximately 30 minutes to maneuver the ship into the entrance of the locks. Several tugboats are responsible for positioning the vessel correctly. Once it enters the first chamber, specialized workers throw mooring lines to attach steel cables to the bow and stern of the ship. These cables are connected to powerful locomotives known as mules, which travel along both sides of the canal on rail tracks. Each of these mules weighs around 50 tons and is capable of towing ships with up to 100 times their own weight. Pulling the ships from both sides simultaneously, the mules slide the vessel slowly into the correct position at each station. The captain's role during this process is extremely tense. The width of the ships is nearly the same as the width of the lock chambers, leaving less than 1 meter of clearance on each side. Every maneuver must be executed with surgical precision. One wrong move could crack the hull of the ship, close the canal, and generate a loss that is almost impossible to calculate. By constantly adjusting cable tension, the locomotives keep the ship perfectly centered inside the chamber. Their movements must be perfectly synchronized at all times to keep the cables taut. With the ship secured and stationary in the correct position, the lockkeeper closes the gates behind the vessel. These closed gates hold back the ocean waters. These massive doors are more than 2 meters thick and are engineered to remain shut even under the enormous pressure of the water volume behind them. Once the gates are closed, operators open the valves that fill the chamber with fresh water from Lake Gatun. Gravity alone drives the water from the lake down into the lock chamber through tunnels located in the chamber floor. The incoming water begins to lift the ship steadily up to the level of the next chamber. The flow of water must maintain a constant rhythm to avoid any turbulence that could cause the ship to shift, which could result in the vessel being crushed against the side walls or even snap the steel cables, creating a catastrophic whiplash effect. It takes just 8 minutes for 80 million liters of water to flood the chamber, raising the ship by 8 meters. Once the ship has been raised to the next level, the locomotives advance to the next chamber. The 680-ton gates swing open, and the vessel is pulled into the middle chamber. The process repeats until the ship reaches the full height of the lake, 26 meters above the Atlantic Ocean. At that point, the cables attached to the mules are released, and the ship continues its journey across Lake Gatun under its own power. This artificial lake, covering an area of 425 square kilometers, considered the largest artificial lake of its era, was formed by damming the Chagres River. Beyond serving as the central navigation corridor of the canal, Lake Gatun is also a critical reserve of fresh water to feed the locks, and plays a vital role in supplying drinking water to the Panamanian population and generating electricity for the region. After navigating for approximately 5 hours through the canal, the ship reaches the far end of Lake Gatun. With 30 kilometers still to go before reaching the Pacific, the vessel faces another formidable challenge: navigating the narrowest section of the entire canal, known as the Culebra Cut, which in English means snake cut or cobra cut. In the construction of the Panama Canal, this stretch represented the greatest engineering achievement of the entire project. The workforce required here was staggering. An almost incomprehensible quantity of explosives had to be used to destroy millions of tons of rock and carve a channel through an entire mountain range. It is estimated that the total amount of explosives used in this phase of construction exceeded the amount used throughout all of World War I. Only through this monumental effort was it possible to complete the Culebra Cut, the 13-kilometer final section of the channel. The waters of Lake Gatun flowed into the cut, allowing the Atlantic and Pacific Oceans to be united for the very first time in history. After navigating through the Culebra Cut, the ship still needs to pass through the Pedro Miguel and Miraflores locks. These two lock systems will return the vessel to sea level and allow it to complete the final 5 kilometers of the canal out into the Pacific Ocean. These locks operate using exactly the same procedures as the Gatun locks, but in reverse. As the ship enters each chamber and is pulled into position by the locomotives, the combination of gravity, valves, and gates drains the water from the chambers, lowering the ship by 26 meters and returning it to sea level, ready to complete its journey to its final destination. If you enjoyed this episode, I ask that you leave your like and share it with your friends. Subscribe to our channel and activate the notification bell to be notified whenever we publish new content. Leave a comment telling us where you watch us from and what you thought of this video. If you want to keep learning, click on one of the recommended videos appearing on your screen. I ask that God bless you and your home, and be always well.